Hello, Biochemistry Simplified. Madam Winnie here, introducing carbohydrates as the first biomolecule. After introducing ourselves to how important biochemistry is, let us now dive into understanding biochemistry. So, I'm going to start by looking at the carbohydrates. Basically, I'll start today by doing the monosaccharides only. So carbohydrates, they are synthesized by photosynthesis in plants, and the best example of the carbohydrates which we know are grains, cereal, bread, sugarcane, name it. There are many examples. So they have a composition of carbon, hydrogen, and oxygen. Classification of these carbohydrates, it doesn't change. We have the monosaccharides, the one sugar, the simple sugars, which you can't hydrolyze further. They are simple such that you can't hydrolyze them further. So the best example of the monosaccharides, we have the glucose, the fructose, and the galactose. Then the second class are the disaccharides. From the name, di means two. So it's a condensation product of two monosaccharide units, but then they are linked together by a glycosidic bond. So a glycosidic bond is found in the carbohydrates. The best examples we know are the sucrose, which is always found in sugar, lactose, which is found in milk, and maltose, which is also a component of Guinness. There is another class which I didn't include here, are the oligosaccharides, but then they are now accommodated in the class of the polysaccharides. Polysaccharides, from the name, it is a polymer of those monosaccharide or disaccharide units, but then it is now a length of those monosaccharide or disaccharide units which are still linked by the glycosidic bond. So the common ones, which are known as the homopolysaccharides, are the starch, glycogen, together with cellulose. I'll start on the monosaccharides today. We will do the monosaccharides in this slide. If you look at the monosaccharides are always drawn into projection. It is either a linear projection, which is always known as the Fischer's projection. Whatever shows on the slide here is a linear projection, which is always known as Fischer's projection, or the Haworth or cyclic projection, which we'll look at it later. So we have to understand the linear projection before we can understand the cyclic projection. So for the monosaccharides that we are going to start off with, we define them as simple sugars. It means you can't hydrolyze them further. They're already simple, so you can't break them down further. So the best example is we have glucose, fructose, and galactose. We talk about one sugar or a simple sugar. They are monosaccharides. You can't hydrolyze them further. They're already simple sugars. And then these monosaccharides, we are going to dwell much on them by looking at how naming of a monosaccharide is done. So naming of a monosaccharide is done based on two criteria. One, the functional group, and two, the number of carbon atoms in the main skeleton. Second criteria for naming of monosaccharides, number of carbon atoms in the main skeleton. So if you are talking about the 3 carbons, we're talking about the triose, 4 carbons tetrose, 5 carbons pentose, 6 carbons hexose. That's how simple it is. So the hexose, we had the glucose and fructose having 6 carbon atoms. We named them hexoses. So what you can say here is, based on the criteria of naming of monosaccharides, we combine both the functional group and the number of carbon atoms. So this first one, its name is known as glyceraldehyde, but as per now, it has an aldehyde group at carbon atom number 1. It is an aldose. It has 3 carbon atoms down the line. It is a triose. So the name will be combined, and having the functional group and the number of carbon atoms, it is an aldo triose. Its common name is glyceraldehyde. The second example has an aldehyde group at carbon atom number 1 for 6 carbon atoms. 1, 2, 3, 4, 5, 6th one. It is an aldehyde, meaning it is an aldose. 6 carbon hexose, it is an aldohexose. Whatever is shown there is D-glucose. Then we have ketose, carbon atom number 2. It is a 6 carbon hexose, so it's known as ketohexose. The functional group and the number of carbon atoms, its name is D-fructose. That is how naming of monosaccharides is done. It is based on 2 criteria: the number of carbon atoms in the main skeleton, as well as we have the functional group. The functional group. So the functional group the functional group functional group here. Functional group. So based on the functional group and the number of carbon atoms in the main skeleton, functional group. Functional group. So that is a functional group, and in blue is the number of carbon atoms in the main skeleton. So we call it an aldohexose, an aldohexose, an aldotriose. So that is the criteria for naming